Good day, learners. Welcome back to our mathematics class. In today's class, we're going to be looking at surds. If you're a new member on this channel and you're just coming across this channel for the first time, kindly subscribe to my channel and click the notification bell for my subsequent content so that you'll be seeing our subsequent lessons. Now, surds. What do we refer to as surds? Surds are irrational numbers, meaning numbers in which their square root keep recurring. Say for instance, when you look at the square roots of 2, it's going to give us 1.1414 and so on like that. It doesn't have a specific number as the square root. The decimal point keeps recurring. Likewise, square roots of 3 and so on like that. That's what we call surds. Now, these surds have different headings: the addition, the subtraction, multiplication, and division of surds. So, let's dive in. Simplification of surds. To simplify surds, we are going to look for two factors in which one of the factors is a perfect square. What I mean by that perfect square means one of the factors has a square root. Now let's look at this. Example 1. Simplify square root of 45. Square root of 45. Then we're going to look for two factors, that is two numbers, in which one of the number has a square root. It's going to be square root of 9 multiplied by 5. Square root of 9 multiplied by 5 can be written as square root of 9 multiplied by square root of 5. So from here, square root of 9 gives us 3 multiplied by square root of 5, which gives 3 roots 5. Second question, square root of 162. 162. Now I want to find a factor in which two factors in which when you multiply you get 162 and one of them must have a perfect square. Okay, if we don't get it directly, you can go by a long division or a division method. 162. What can go here? We have 2. 2 goes here, we have 81. Okay, we're just going far. Look at this 81. From this 81 we can have 9 times 9. So 9 times 9 is 81. So this will be square root of 81 multiplied by 2. So we have square root of 81 multiplied by square root of 2. So 1 square root of 81, that is 9, multiplied by square root of 2, which gives 9 root 2. Question C. Square root of x squared y can be written as square root of x squared multiplied by square root of y. This square cancels square roots, so we have x root y. The D question, 3 square root of 50. We have 3 square root multiplied by square root of. So 50 can be written as 25 multiplied by 2. That is 3 multiplied by square root of 25 multiplied by square root of 2. So 3 multiplied by square root of 25 is what? 5 multiplied by square root of 2. So 3 times 5 we have 15 multiplied by square root of 2, which gives 15 root 2. So this is how to simplify surd. Example 2. Express the following as the square root of a single number. We want to express this as a square root of a single number. That is, the first one, a, we have 2 root 5. As a square root of a single number means that we don't want these 2. We want these 2 to be inside this square root and form a single number. Now, in order to make these 2 to come in, it means we have to double it. Because when you look at the square root of 25, it means 5. Meaning when you double 5, 5 times 5 will give us 25. Definitely, this will also give us square root of, so we have 2 multiplied by 2. Then it has 5 multiplied by 5, which is square root of 2 times 2 we have 4. 4 times 5 we have 20. So square root of 20. Meaning that 2 root 5 means square root of 20. The second one, 7 root 3 means square root of 7 multiplied by 7 multiplied by 3. So we have square root of. So 7 times 7 is 49. So 49 times 3, we have 147. So you have expressed this sort as a single number of having square roots. Addition and subtraction of sorts. Before we can add or subtract any sort, 2 or more sorts, they must be like sort. Meaning that the sorts must be the same, having the same square roots. They must have the same square before we can add it. Generally, let's say for instance we have square root of A plus square root of A. These are sorts that are like sorts. Because they have the same A, we can add them together. What's the coefficient? Meaning the number here is 1. The number here is 1. 1 plus 1, we have 2. Then you take your square root of what? A. This is likened to our algebraic equation that says x plus x. S is standing as 1. Under S standing as 1. 1 plus 1, we have 2. Because they are in terms of S, we have what? X. Or we say x plus 2x. This has x, this has s. They are the same. This standing as 1. 1 plus 2, we have 3. In terms of what? X, 3x. Likewise, square root of A plus square root of A is going to give us 2 root A. Also, let's assume we have square root of 2 root A minus square root of A. Look at this. 2 root A minus square root of A. Both of them are like sorts. Then we are going to subtract the coefficient 2 minus 1. We are going to have 1. Then times of what? Square root of what? A. But in mathematics, you don't need to show that one. We have root what? A. These are addition and subtraction of sort. They must be what? They must be the same. Secondly is we must simplify the sort to the lowest term if possible. That is, we simplify to the lowest level before we can write our final answer. So let's apply this. Example 3. Simplify the following. Question A. 4 root 2 plus 6 root 2. So these are like sorts in root 2. So we have 4 plus 6, we have 10 root 2. Second question. 3 root 5 minus 7 root 5. So we have 3 minus 7. We have minus 4 root 5. Then the C part of it, we have 3 root 8 plus square root of 50. The first thing is to express this 8 as two factors in which one of the factors we have a perfect square. Likewise, have 50 as well. So we're going to have 3 square root of 8 can be written as 4 times 2 plus square root of 50, 25 times 2. So we have 3 multiplied by. What is square root of 4? We have 2 root 2 plus 12 to 25, 5 root 2. That is 3 times 2, we have 6 root 2 plus 5 root 2. Now these are in terms of square root of 2. We have to express them by adding them together. So we have 6 plus 5, that is what? 11 square root of 2. You can see how very easy sort is. Don't forget to like this program, love it and share it. Now let's move on to question D. Now 2 roots 27 can be written as 2 square root of 9 times 3, that is 27, plus square root of 25 can be written as 25, that is 75 can be written as 25 multiplied by 3 minus 5 square root of 4 times 3. So we have 2 multiplied by, what is square root of 9? We have 3 root 3 plus square root of 25, 5 root 3 minus square root, that's 5 multiplied by square root of 4 is 2 root 3. So we have 2 times 3, we have 6 root 3 plus 5 root 3 minus 5 times 2, 10 root 3. Now, finally, 6 plus 5, don't forget they are in root 3, they are like sorts. 6 plus 5, we have 11. 11 minus 10, we have 1. Then in terms of square root of what? 3. And you know in mathematics, we don't write 1x. Instead, we write what? Ordinary x. So, not 1 root 3, but ordinary what? Root 3. Multiplication of sorts. Now, talking about to multiply sorts, we still use the same process as addition and subtraction. But in this case, in the general type of form of multiplication, when you have square root of a, b, it can be written as square root of a multiplied by square root of b. So these can be multiplied together, and also it can be interchanged. We can also see it is the same thing as square root of BA, which is equals to square root of B multiplied by square root of A in terms of multiplication. So in multiplication of sort, when we want to simplify it, the whole number comes together, the sort also comes together. You multiply the whole numbers together, you also multiply the sort together. So let's look at the examples. Example 4. Simplify the following. The first one, we want to simplify square root of 27 multiplied by square root of 50. 27 can be expressed as 9 multiplied by 3, while 50 can be expressed as 25 multiplied by 2. So what is the square root of 9? We have 3, then it will be left with root 3 multiplied by square root of 25, we have 5 root 2. Then all numbers together and the one with square root together. 3 multiplied by 5 multiplied by square root of 3 multiplied by square root of 2. 3 times 5 we have 15 multiplied by square root of, so this is 3, the first one is 3, second one is 2. So it will become 3 multiplied by 2. So finally, we have 15 square root of, so 3 multiplied by 2, we have 6. This 6, there's no two factors that when you multiply them, one of them will have a perfect square. So we leave our answer that way. So the final answer is 15 root 6. Second question. Square root of 12 multiplied by 3 square root of 60. So we can have square root of 12 is 4 multiplied by 3. Then multiplied by 3 square root of 6. So we have 4 multiplied by 15. So here we now have 1 square root of 4, 2 root 3, multiplied by 3 multiplied by square root of 4, 2 root 15. So we now have 2 root 3 multiplied by 3 multiplied by 2, we have 6 root 15. Then the whole number will be multiplied together, 2 multiplied by 6, square root of 3 multiplied by 15. So we have 2 times 6, that is 12, square root of 3 times 15, we have 45. Can this 45 be expressed further again, in which we have two factors that we can get a perfect square of one of them? Yes, we can have 12 square root of 45 will be 9 multiplied by 5. That is 12 times, what is the square root of 9? We have 3, square root of 5. Then 12 times 3, that is 36 root 5. So the final answer of this is 36 root 5. So let us now move down to the question C. If you have not subscribed to my channel, kindly do so and click the notification bell. So if you don't click that bell, you won't be able to see my subsequent lesson. So let's move on. Question C. 2 square root of 5 raised power square. This square means we have to express this twice. That is 2 square root of 5 times 2 square root of 5. Square root of 5. So that is all numbers together, 2 multiplied by 2 Then square root of 5 times square root of 5. 2 times 2 we have 4 times square root of 5 times 5. That is what? 25. And what is square root of 25? So 4 times 5. That is what? 20. So in multiplication, when we have square root of a multiplied by square root of a, our final answer is a. So as we move on, instead of us writing square root of 25 as 5 times 5, when we have square root of 5 multiplied by square root of 5, our final answer is 5. So we don't need to move through square root of 25, then we now get to square root of 5. So when we say square root 5 times root 5, it will give us our 5. Because square root of that 25 is what? 5. As we move on in our subsequent examples. Example 5. Simplify the following. The first one, want to simplify square root of 2 multiplied by square root of 3 multiplied by square root of 5 multiplied by square root of 12 multiplied by square root of 45 multiplied by square root of 50. We can take this one under the same umbrella. 2 times 3 times 5 times 12 times 45 times 50 all have a square root. So how do we go about it? I can multiply 2 times 50 can give me 100. I can find the square root of 100. So it will be 2 times 50 multiplied by another one. 2 times 50. So I've taken this one. What again? Out of 3 times 12, that is 36. 3 times 12, 36. I've taken that one as well. Okay. Which one again? 45 times 5, what will that give? This 5. Okay. 5 multiplied by 45 with their square roots. So we have 2 times 5, we have 2 times 50, we have 100 multiplied by 36 multiplied by, this is 5, 2225, all square roots. So it can be, source of 100 is 10 times 6 times 15. So 10 times 6 we have 60. 60 multiplied by 15 we have 900. Question B. We have square root of 3 multiplied by square root of 6. So we have square root of 3 multiplied by 6, that is square root of 18. So this 18, you can look for two factors, and when you multiply, you get 18. That is square root of 9 times 2. And square root of 9 is 3. Square root of what? 2. So 3 root 2. So this is how to undergo the addition, subtraction, and multiplication of surds. In our next class, we are going to look at the division and other subtopic of surds. Kindly attempt the following assignments coming. Kindly go through these assignments in order to check your understanding of these surds. I remain Latif Ismaila Akombi, your mathematics and chemistry tutor. I will see you in the next class. Thank you.